Now we are going to see another problem, that is beam with consistent matrix. This is the consistent matrix formula: rho AL by 420, 156, 22L, 54 minus 13L, 22L, 4L square, 13L. It goes on. So this has to be magnetic. The question may ask in both lumped matrix and consistent matrix, or they may tell you to use only consistent matrix. So there is no difference. Find out the beam has been, the problem is given. The steps I'll tell you that. The simply supported beam is here given. First to find the stiffness matrix of the element by dividing, discretizing the element. Then you will get two elements. The stiffness matrix of element 1, stiffness of element, assemble that. Then apply consistent matrix or lumped matrix. If according to the question, then the determinant coefficient of the matrix, homogeneous set of equations of that matrix is set to 0, and find out the determinant, you will get some equation. From there you can easily find it out. This is the step of the vibration. So here it is a simply supported beam. So now we'll read consider the simply supported beam shown in the figure. Length L is equal to 1 meter, E is equal to 2 into 10 to the power of 11 Newton per meter square. So area of a cross section is 30 centimeters square. Everything it is given. So everything is given. The data has been converted. Centimeter here, this is centimeter square. So this has been corrected and conversion made. This is converted into Newton, 7800 into 9.81. So you will get this value. So all this conversion you should make very carefully. According to this here, centimeter is given. Don't convert everything into centimeter. See to that the maximum unit what it is. So the meters are the maximum unit. So convert that 1 centimeter into meters. So it is, if it is not nothing wrong if you convert everything into centimeters. So I have discretized. It is 0.5 mm, final element, this element. Then V1 theta 1, V2 theta 2, V2 theta 3. So this is again here it is fixed. Both ends are hinged. Horizontal, vertical, no rotations, no rotations, and displacements will be there. Here also the same thing. So okay. Now this is the equation we are going to. Element 1, this is the stiffness matrix. Element 2, this is the stiffness matrix. Element 2, what is here you have to do? You substitute L value here, 0.5. Everything I substituted, and I got this value. This is all a substitution. It is given here, 0.5 cube. So I got this equation. After dividing this completely by here, simplify this and divide whole throughout by this one. So I got this. And this is 160, and I got this one. So okay. Now I am getting it, and now this is the K2. Same thing will be K2 because value is 0.5. So this is also the same thing. The material is the same, moment of inertia is the same, and L is also the same. So the value will be same thing. So the same value of written here. So no need of calculating again. So assemble the stiffness matrix. We have to do again as per. Write this notes 3, 4, 5, 6, 1, 2, 3. So you will get this. So now after finding out that we have find out the stiffness matrix for the element 1, stiffness matrix for the element 2. Now we have assembled that. Now what next subject is for in vibrations, what you have to do? Mass matrix. Here I am using consistent matrix. I am not using lumped mass matrix. You can use. Nothing wrong in that. Both you can use and compare it. So this is the formula rho AL 420, and this is 150. So in this L we have to substitute the 0.5 value. That because 0.5 is the length is given. Here in this problem you have to substitute 0.5 for the matrix element 1. So I got this value after substituting. So I got this value. So throughoutly I have divided. Same thing. Now similarly, so same value, same whatever I have done set in the stiffness matrix, same value, same Young's model, same material. So everything similarly I got this. So this and this end should be assembled. So I have assembled this completely. I have assembled this value. So this is the M1 constant value, this value completely, and this is the second matrix, and this are assembled, and I got this value. I got this complete value, and now I got assembled stiffness matrix, assembled mass matrix. So I have to substitute in the finite elemental matrix. So K m square omega square u is equal to 0. So I have substituted. and here v1 theta won't be 0, v3 theta will be 0, only v2 theta, because both ends are hinged, there is no displacement at all. So fixed, no displacements and rotations are 0, both ends are fixed. So this is what I get. So here this is the equation I have substituted, and 0 0 0 0 0. So these are, you know that the zeros rows must be deleted, columns must be deleted, everything on deleting first, second, fifth, sixth rows and columns of the matrix, we got this equation. Now I have to set this determinant matrix, coefficient matrix of this, coefficient of matrix of this is this one. This should be set to 0. The determinant of the coefficient matrix is set to 0. Now I am minusing this one. Minusing with 160 into 24 minus omega square 85.26, this one. So you minus it, this and this row, this minus this, and this minus this value minus this value, this value minus this value. So I got this 160 into 2, 320 minus omega square 0.546. So I am getting now. Okay, so you have to know this matrix subtraction, simplify, cross multiplication, and you multiply this and this and this and this, and you get this W4. You got the omega 4 you are getting. So omega 4 I am setting into W square. If omega 4 is lambda square, what will be the omega square? Lambda, obviously. So this is the value. So I am substituting here this equation. Instead of omega 4, I am substituting lambda square. Lambda, this I am getting it. So what happened? Now this is the equation, you know that. What is this equation? A square, lambda, but this is the equation, the quadratic equation. You make it out and find it out the answer. So I got this equation. This b square minus 4ac beta, so this is the one. I am substituting this equation BAC, and I got this value lambda. So lambda 1, lambda 2, lambda 1 value, lambda 2. Omega square is equal to lambda, we know. Substitute here. We got this. Omega is equal to lambda, you get this. So omega 1 is equal to lambda. Lambda value is what? This one, this is 1. Lambda 2 value, again similarly the lambda 2 value. Lambda 2 value is what? This one. So root of this will be this one. So this is the 6 points. This is 6.708 radian per seconds. This is 24.21 radian per seconds. That's all. So what we have to do in vibration, the lumped matrix and consistent matrix. Then first to find out the stiffness matrix for how many elements you are discretized. All the elements what you have to do, assemble it. That next to find out the mass matrix using lumped or consistent. Then assemble it. Then substitute that both the matrix in the where you have to multiply finite element equation. In that finite element, the coefficient matrix of the determinant is set to 0. And find out the determinant, and you will find that some algebraic equation. Necessary arrangement should be W square is equal to lambda, W4 is equal to lambda. Now, according to the equation, it is a logic, and it is a logic that you should make it out. It is not a rule, hard and fast rule. Each and every problem it differs. So please simplify the problem in a proper way. Look into that and strike off the whatever is necessary. Whether you are to divide it or multiply it, it depends upon you. So please, this is the very easiest problem, and next class I will send you all the formulas and everything. Thank you.